Okay, in this video we are going to talk about the basics of linear equations, specifically looking at one variable equations, and then we're going to look at how we would apply some of these linear equations to applications. So the biggest thing that you need to know is that application is essentially a big fancy word for story problem, and so we're going to look at some of those linear story problems as well to talk about how to attack them and solve them. So first we need to start out with the basics, which is linear equations. So there's a few things that we need to remember. First and foremost, we need to remember that linear equations have a power of 1. Okay? What that actually means is that the exponent is 1. Okay. The other thing that we know about linears is that they typically have only one solution. And this occurs because we are talking about a straight line. And so typically when we are solving, you're going to have one solution. Now there are some instances where that doesn't happen, and those would be special cases of equations. And we're going to look at a couple of those as we go. But in general, we've got a one solution situation. Now the way you're going to solve these is that you simply want to isolate the variable that you have completely over to one side of your equation and leave all of your numbers on the other. So if we look at this first one, notice my variable here is x's, and I have x's on both sides. However, before I can move them across the equation, I have to be able to do a little bit of math to start with. On this left-hand side, I've got this 7 out in front, and so I have to do what's called distribute. Distribute says I'm going to take the 7 and I am going to multiply it through my parentheses and thus get myself an answer. So if I go ahead and do that, 7 times 3 is going to give me 21, and then don't forget your x's along for the ride. And then I have 7 times 6, so 7 times 6 is going to give me 42, and that was the left hand side of my equation. Now we also have the right hand side of the equation, and the right hand side of the equation, notice you want to be very careful. What has to multiply through these back parentheses is not the 11, but it is this negative sign here. This is what is going to multiply through my parentheses. So I'm going to bring my 11 down, and then I'm going to multiply through. Well, to multiply by negative means everything changes signs. So this is a negative x, and this is a minus 2. Now the next thing that you want to do is you actually want to combine like terms. So you want to look and see if you have terms in your equation on either the left side or the right side that can be combined before you do anything else. In this case we do. We have this 11 and we have this negative 2. And so we need to go ahead and combine these using the addition and subtraction as we see fit, and in this case I have 11 minus 2. So if I'm looking at this right hand side, 11 minus 2 is going to leave me with 9, and then minus x. Now if you go to the left hand side, notice there's nothing I can do in order to combine, as these are two different terms, so I'm just going to rewrite them as 21x plus my 42. Okay. So now this is the part where we have to isolate the variables, and so what I'm going to do is I like to keep my x positive, that way I don't have to worry about negative signs in the end. So I'm going to take this x term here and I am going to move it to the other side of my equation. Now in order to move it, I have to look at its sign, and this sign here is a negative sign, meaning it is being subtracted. So in order to move it, says that I have to add across my equal sign. Okay. Now that means if I am moving my x over to the left-hand side, well, that means I have to move my number over to the right-hand side. So I have to move this number here, and I'm going to move it this direction over to the right-hand side. Again, you need to look at its sign. The sign here is positive, which means it's being added on the left side. So to move it says I have to subtract. So here we're going to subtract and thus be able to move our terms. So I had a 21x to start with. I have to move my x by adding, so I'm going to add my x over on the left side. And then if I look at the right, I had a 9 to start with. I have to move my 42 over by subtraction, so I'm going to subtract my 42, and thus I have my equation totally set up. So now all I have to do at this point is I just simply have to isolate the x variable. So I do that by doing a little bit more algebra. I have to add these together to figure out how many total x's I have. Well, 21 plus 1 gives you 22x. And then on the other side, I have to subtract. So pay very close attention. Small number minus a big number means my answer is going to be negative. And 9 minus 42 is going to give me a negative 33. Now the last thing we need to do is get x completely by itself, which means here I need to go ahead and divide both sides by that 22, thus giving me that x is equal to my negative 33 over 22. Now at this point, the biggest thing you have to remember to do is you have to reduce. Reduce is a fancy word for simplify. In other words, it's try and see if you can shrink your fraction down as small as it can go. And you do that by looking for what's common between your top and bottom. So here I have 33 and a 22. What's common there is 11. So I'm going to divide out my 11, thus reducing my fraction. So when I divide the 11 out, that means I'm left with x is going to be negative 3 over 2. And this was the overall result that we were looking for. Okay. So here what you can see is clearly we have one solution. And in this one solution, if I were to take this negative 3/2 and plug that back in to my equation, what you would actually find is that both the left and the right hand side equal each other and balance out. Okay, so this would be considered a one solution equation. So let's look at a different one. So here I have 10x minus 3 equals 8 plus a 10x. Okay, so I'm going to do a little trick here in the beginning, which is this left side says 10x minus 3, so I'm just going to rewrite that. But I'm going to rewrite my right hand side so that it matches. So this is going to actually be 10x plus 8. Notice because it's addition, you can go ahead and do that. It doesn't change anything. And what I want you to notice is I have a 10x and a 10x. So notice these are the same. So if I were to try and combine my terms, one idea that a lot of students have is we would move, say, the 3 over and we would move the 10 over. So if we were to do that, we would subtract a 10x from both sides, and what you're going to notice is that they completely disappear. So if we go ahead and move this 10x over to the right hand side, because it's positive, it means here we have to subtract. And in doing so, 10x minus 10x leaves us with no x's. So essentially our equation becomes negative 3 equals 8. Now the biggest thing you should notice about this is that this is not true. This is called a false statement. And a false statement essentially is telling you that you have no solutions. What that means is that there is nothing that you could ever plug in for x into this equation that would actually result in giving you a solution. Meaning there is no x value that you could plug into this equation here that would result in these two sides equaling each other. They will always and forever be something different. Therefore, it's called a false statement, and those would be no solutions. This is an example of that special type that I was talking about a few minutes ago, in that most of your equations will be like this first example and have one solution, but some of them are this special case and have no solution at all. Okay? So let's look at one that's a little bit more complicated. Notice with this one we have some fractions here. These fractions have expressions in their numerators, which means they're actually called rationals. And in this, in order to combine, you have to remember the biggest rule we have for fractions. Okay? So the rule that I am talking about is that you must have common denominators if you want to add or subtract. Now notice in this one I do not have common denominators, and so I have to be able to create or find my common denominator. So there's a couple ways that you can go about doing this. One way is you can take all of these denominators and you can multiply them together, and that would be a common denominator. However, what you need to notice is that in some instances that denominator is not the least common denominator. Any common denominator will work to solve this problem. Obviously, the least common denominator will require the least amount of steps in your reduction process at the end. So if all else fails and you have no idea of anything else to do, then just simply multiply all your denominators together, and that will give you a common denominator. In this case, if you look at 2, 8, and 4, what we know about this is that we can find my least common denominator. And the way I know that is I know that 2 can go into 8 evenly, and 4 can go into 8 evenly, and 8 can go into 8 evenly. So that makes 8 my least common multiple. Now, what do I want to do with that? I want to take my least common multiple, and because I have this equal sign here, I want to multiply the entire equation by that 8. And when I do that, what you're going to notice is that the denominator is going to peel away and disappear, and what you're going to be left with is just a linear equation. Okay, so this is what I like to call removing your fraction and making things a little bit more easier. So I'm going to take this 8 and I have to multiply it to this top term, to the middle term, and to my last term. Okay? So there's a few ways you can show that. You can show that by doing individual steps. So by stating I have 8 times 4x minus 3 over 2. My sign here is addition, and then it's 8 times 3 over 8 equals 8 times my 7x plus 3 over 4. Or if you're somebody who's able to keep it straight in your head as you go, then just simply doing this top step and then showing what it equals afterwards would be enough for most instructors. Okay, so whether you need this intermediate step or you don't is personal preference and completely up to you. Remember, math is choose your own adventure, and your goal is just simply to make it to the end. And whatever you have to do to get there is what you have to do to get there. So in this intermediate step, I'm looking at each individual fraction all on their own. So I have 8 times something over 2. So the only thing I actually care about in this point is the 8 and the 2. And so I want to look at how many times does 2 go into 8. In other words, 8 over 2 reduces down to 4. So this is really going to be 4 times, and then I had 4x minus 3 left over. So now I need to add this to the next. Again, what I care about is this diagonal here. So it's the 8 over the denominator. And when we reduce that, you end up with 1. So 1 times 3 is 3. And then one more time, we care just about that diagonal. So we have 8 over 4. When we reduce that down, that leaves us with 2. And then, of course, our leftover was 7x plus 3. Now, if you look at this, this now has you all set up for the exact same thing that we did in the very beginning, which is just simply solve for x. So the first thing I need to do is I have to distribute through my parentheses of my first one, and I have to distribute through the parentheses of my second one. The biggest thing you need to remember here is you need to distribute through the entire parentheses. So I have 4 times 4x minus 3, and so I need to do 4 times 4x, and I need to do 4 times 3. So 4 times 4x is going to give me 16x, and then 4 times 3 is 12, and remember I've got a negative here, so this is a negative 12. I then have to add 3 to it and come across to my other side. So here I have 2 times 7x gives me 14x, 2 times 3 gives me 6. The sign was positive, so I'm adding. I need to combine my terms, so first I need to combine these two terms here. So this is going to give me 16x minus 9 is equal to 14x plus 6. And now is where you can go ahead and shift back and forth across the equal sign. So here I have this 14x, which is less than 16, so I'm going to move it over to the other side. Since that 14x is positive, in order to move it means I have to subtract. At the same time, I have this negative 9 here, which I have to move to its other side. Because this is already being subtracted, to move it says I have to add. And so I'm going to reshuffle my terms and put them on their proper sides. So I have 16x minus 14x is equal to 6 plus 9. 16 minus 14 is going to give you a 2x is equal to, and then 6 plus 9 gives you 15. The last thing you need to do is divide 2 out of both sides. So x is equal to 15 over 2. And so that there is an example of working with rationals when you're trying to simply solve a linear equation. Okay. Another thing that we do with linear equations fairly often is we do what's called absolute value. Okay, and absolute values can be a lot of fun as long as you understand the rules. Absolute value is that double bar, the straight up and down vertical bars that you see. And essentially what they mean is that no matter what's inside the absolute value bar, what comes out of it is going to be positive. Okay, so when I think of absolute values, I like to think of them the way that I was taught way back in elementary school. I had a teacher and we thought he was absolutely insane, but he was really good, and the way that he taught things really stuck with me, and I like to be able to share. And so when I think about absolute values, I teach it the way he did. And what he said is that an absolute value bar is kind of like a shower. So here we've got our lovely shower, and we've got a positive x inside. So an absolute value is like a shower. So you get up in the morning, and the first thing you do after your alarm goes off is you're going to just jump in the shower because that's your routine. Of course, I would assume that you would turn on the water and use soap, but you know, to each their own. But then, of course, when you come back out of that shower and take a look in the mirror, what you would notice is that you looked the same going in as you did coming out. So if you were positive in the shower, then you're still positive coming out. Okay. Now, let's say, for example, you have a 6-year-old son, and that 6-year-old son goes to school, and he goes to school quite a ways away from where you live. And let's just say one day he decided that he was going to go and find the only puddle out on the playground that was muddy. And he decided that he was going to spend the afternoon jumping in that mud puddle, thus coating himself from head to toe. Now let's say you're his parent, and his teachers did not tell you prior to you driving all the way out to pick him up that he was covered in mud from head to toe. And so you drive to pick him up, and of course you still have to return to your job after you're done. And you're sitting there waiting, and he comes running out from the school, and he jumps into your arms, and guess what? You are now caked in mud from head to toe. And not only has this now happened at school, but you have to put your son's muddy self and your muddy self in your car and drive your car for 45 minutes to get back to your house. So needless to say, that is a true story. However, what would happen when you finally get your son back home to your house is you're going to take your muddy little son and you are going to stick him in the shower. So he is now caked in mud head to toe. And so I would assume that you would turn on the water and use some soap, but you know, again, to everybody their own. But in my case, when I turned on the water, all that mud washed down the drain, and when my son got out of the shower, all the mud was gone, thus leaving him positive. So, the moral of my crazy shower story is that with absolute values, it does not matter if you're positive or if you're negative going into the absolute value, you will come out as a positive result. That being said, it does mean that all absolute values will have two solutions, or that you have to check for. So you have to look for the positive and you have to look for the negative. You need to take both of them into account when creating your absolute value. Okay? Now, once you take them both into account, please be aware that sometimes one of your solutions won't work. So you need to make sure that you are in the habit of checking your solutions when you're done. Okay? So here I have an absolute value problem, and notice in this problem my absolute value is not by itself. Okay, so if you paid close attention to my little showers here, notice there was absolutely nothing on the outside over here. We just simply had the absolute value. So here I've got some buddies. I've got this 5 and I've got this minus. So the first thing that you have to do is you have to do what's called isolate the absolute value. Isolating the absolute value essentially means you have to get it completely by itself before you can do anything at all. I like to think of it as you have to unwrap your candy bar before you bite in and eat the chocolate inside. Unless you're somebody who likes to eat wrappers, most people would unwrap the candy bar. Well, it's the same thing here. I have a wrapper on the outside of my absolute value bar that I have to remove. So the first thing I have to do is I need to move this 5. And so in order to do that, it is positive, which means I have to subtract. So this becomes negative absolute value of 4x plus 3 equals, and we need to do 2 minus 5, gives us a negative 3 as a result. Now I need to divide everything by that negative in order to remove it. The other way you can look at it is you can look at multiplying everything by the negative. But the end result is that your absolute value must be a positive. Okay, so again, we still have this negative on the outside, so we still have another wrapper, kind of like a Reese's peanut butter cup has 2 wrappers instead of 1. And so we have to remove that one as well. So to do that, says we now have the absolute value of 4x plus 3 equals 3. Once you get your absolute value completely isolated, there's a couple things we can do. First, remember we have to take the positive and the negative into account. You can either do that through the inside of your absolute value, or the trick that I like to use is I have to take my GUI center and I have to set it equal to the positive, and I need to take my GUI center and I need to set it equal to the negative. Notice I'm taking the positive and negative into account, and instead of trying to worry about messing with my signs inside here, I've made it a little easier on myself. Now if you didn't want to do it this way, doing it the other way would get you the same result. You just need to remember that this is a binomial and the negative would have to be applied to both. Okay. So here we just simply have to solve both equations for x. So in my first one, I'm going to subtract the 3 from both sides. When I do that, my 4x comes down, and I have 3 minus 3 gives me 0. Divide everything by 4, and x is 0. And then on the other side, again, I need to subtract 3 from both sides. My 4x comes down, and I have negative 3 minus 3 gives me a negative 6. And then at this point I need to divide everything by 4, so x is equal to negative 6 over 4, which we have to reduce. Notice 6 and 4 have a 2 in common, so this becomes negative 3 over 2. Now the last thing that you need to do is we have 2 solutions, but we have to check. You need to verify if they work or not. The way you verify is you have to plug them in. So here you need to check your solutions. So I'm going to go back to my original equation here. So I have 5 minus the absolute value of 4 times 0 plus 3, and that should equal 2 as a result. So here I'm going to do the math. This becomes 4 minus 4 times 0 is 0 plus 3 is 3. So this is the absolute value of 3 equals 2. Remember, your rule says when you evaluate your absolute value, it always comes out positive. So I have 5 minus 3 equals 2. And is this a true statement? Well, yes it is. Therefore, that first solution works. You need to test both and make sure that they both work. So we're going to do just that. Here we're going to check. So we have, again, 5 minus the absolute value of 4 times. And in this case I have negative 3 over 2. So I've got negative 3 over 2. And then this is plus 3 equals negative 3. So we need to actually take a closer look at this. This is still 5 minus, but we need to know what's going on inside my absolute value here. Okay. So we have 4 times negative 3 over 2. So I look at 4 over 2, and that's going to reduce down to 2. 2 times negative 3 is a negative 6 plus 3 equals a negative 3. Sorry, equals a positive 2. So here again I've got 5 minus the absolute value. Negative 6 plus 3 is a negative 3 equals 2. Evaluate your absolute value and we end up with 5 minus 3 equals 2, which again is a true statement. Okay. Since both of these statements work, it means you do have 2 solutions. And so again, your solutions here would be that x equals 0 and x equals negative 3 halves. Okay. Okay. Last but not least, we need to look at what happens if you are given 2 absolute values that you have to work with. Well, again, the same principle is going to apply, where you have to isolate one of your absolute values completely. So here, in this case, these are being subtracted. So I'm going to go ahead and take this absolute value here, and I'm going to move it through addition to the other side. So this becomes the absolute value of 6y minus 3 equals the absolute value of 5y plus 5. Once you do that, you have to do what's called choose which absolute value is the answer. Okay. So what do I mean? I mean you have 2 absolute values. You have to choose one of the absolute values to be what's called the answer value, and one of the absolute values to mimic the absolute value. It doesn't matter which one you choose. So here, just to make things easy, I'm going to choose that the 6y minus 3 remains my absolute value, and that means the 5y plus 5 becomes the answer. So this is 5y plus 5. So my absolute value is now completely isolated, which means I need to apply the rule. So the rule says I'm going to take my absolute value, so 6y minus 3, and I'm going to set it equal to the positive of my result, which is 5y plus 5, and I'm going to set it equal, so 6y minus 3 equals the negative of my result, which was 5y plus 5. I then have to solve both equations. So let's start with the equation on the left. I'm looking at the positive of my result, so I don't have to change anything. So this is going to be 6y minus 3 equals 5y plus 5. Again, I want to keep my variable positive, so I'm going to take this 5y and I'm going to move it. It is positive, so to move it says I have to subtract. That means I'm then going to take this negative 3 part and I'm going to move it over. Since it is negative, to move it says I have to add. So I have 6y minus 5y, and then I have 5 plus 3. 6y minus 5y leaves me with y. 5 plus 3 is 8. Now I need to look at the second one. So here I have a negative. So this negative here has to be distributed. So I'm going to take this negative and I have to distribute it through both sides of my answer. So this is going to give me that 6y minus 3 is equal to negative 5y minus 5. Now, again, just like before, I have to take it and I have to be able to combine my terms. So here I have that I want to keep things positive to the best of my ability. And so in order to do that, says I'm going to take my 5y here and I'm going to move it. Because it is negative, to move it says I have to add. At the same time, I'm going to then take my negative 3 and I'm going to move it to the other side. Again, it's negative, so to move it says I have to add. So this is going to give me 6y plus 5y is equal to my negative 5 plus 3. So my 6y plus 5y will give me 11y, and this is going to equal negative 5 plus 3, which is a negative 2. Divide everything by 11, so y is negative 2 over 11. Okay, and that is just one such example where you have to solve both. Okay. Now the other thing that we have to do with this, now that we've gotten our two possible solutions, we have to determine if they're actually solutions or not. And so in order to do that, says that we have to plug them into the original equation and see if it works. So here, my original equation, I would come all the way up to the beginning. And so I have to go ahead and check this work. So I'm going to do that. First I have that I need to check if y equals 8. So I have the absolute value of 6 times 8 minus 3. I got to subtract the absolute value of 5 times 8 plus 5, and this should give me 0 as a result. So again, I need to simplify. 6 times 8 is 48 minus 3. And then I have 6 times 5 is 40 plus 5 equals 0. 48 minus 3 is going to give me 45. And then 40 plus 5 is going to give me 45. Apply my absolute values, and whatever comes out is going to be positive. So this is 45. My sign was still negative. Apply my absolute value again. Here I get 45. And what you notice is that 0 equals 0, which is a true statement. Thus, y equals 8 works. Now we need to verify our other. Okay, so again, we need to check our work. So I have the absolute value of 6 times negative 2 over 11 minus 3 minus the absolute value of 5 times negative 2 over 11 plus 5. And we're checking that this equals 0. Okay, that's our goal. So we have to go ahead and play with our fractions. So here I have the absolute value, multiply straight across the top. 6 times negative 2 is a negative 12 over 11. And then I've got this minus sign, and I need to turn 3 into something over 11 so that I can combine my fractions. So I have to multiply 3 top and bottom by 11. So this is really going to be 33 over 11. I'm still subtracting, and now I need to work with my other one. Again, multiply straight across the top, and you get a negative 10 over 11. And then I have this 5 that I once again want to turn into something over 11. So that's going to multiply top and bottom by 11. So I have plus 55 over 11. And I'm hoping that this is going to equal 0. So I have negative 12 minus 33. And that's going to give me a negative 45 over 11. And looking at the other side, I have a negative 10 over 11 plus 55 is going to give me 45 over 11. Again, apply the absolute value. So this is going to be 45 over 11 minus 45 over 11 equals 0. That is a true statement. Therefore, both solutions work. Okay? So you need to make sure when you are working problems like these that you are always verifying that your solutions are giving you the answers that you expected. If you have any questions, please make sure that you let me know either by commenting or sending me an email. Otherwise, I will see you next time.